All right, this is a great topic because it's basically a review topic, which means we're going to jump in with examples. So, in our last lesson, we kind of talked about what a solution to a quadratic equation means, and all that, how it relates to the parabolas, the graphs, how a quadratic equation relates to a quadratic function, and all of those things. So, what if we're going to solve a quadratic equation, right? So, there's a quadratic equation is all this stuff equals zero, and as you might guess from the title of this lesson, we're going to solve it by factoring. Now, we're going to actually sprinkle in another topic or two in here. So, when we're solving these, what we're going for, our goal when we're solving by factoring is our goal is to get and turn it into some products, some things in parentheses, product being multiplication equal to zero. So everything on this side and it all factored completely equal to zero. Because if we do that, then remember we can take and split each factor into zero and get the solution to the equation. So let's dive in and do some examples. We did this in our unit 0, our review unit. In this course, and then it's also in Algebra 1 and all of that stuff. So this one, we're going to start by factoring out a GCF. We're always looking for a GCF first, greatest common factor. So if we look at these terms, what's in common between these terms? Well, they both have an X, and they both, 8 goes into both of these numbers. So we're going to take and we're going to pull out an 8X. And once we pull that out, we're going to open parentheses. We're going to write what's left. Now, to remind you what's going on here, I won't write this necessarily on every one, but what we're doing is we're dividing each one of these by the common factor. So dividing it by 8x, and that's how we get what's inside the parentheses. So 16 divided by 8 is, of course, 2. X squared divided by x is x. And 8x divided by 8x is 1. So this is plus 1 equals 0. So once we have our equation here completely factored over here on this side and equal to 0, our next step, as I reminded you a minute ago, is to split it into two things where we set each factor equal to 0. So we're going to say 8x equals 0, and we're going to say 2x plus 1 equals 0. And then we solve each one of these baby equations, right? This one, we've got 8 attached to the x through multiplication. So we're going to divide by 8 on both sides, divide by 8, divide by 8. And we end up with x equals 0 because 0 divided by 8 is 0. So there's one of our answers. So let's solve this one over here. We're going to add 1. That cancels. Then we've got 2x equals 1. And then we're going to divide by 2 on both sides to get rid of that 2. So x equals 1/2. It's that simple. Easy peasy. Let's do a handful more examples, and then we're going to be through. All right, so we're going to solve this one. Now, this time we've got a trinomial. So go back in our review brain and remember how to solve a trinomial, right? And what I teach in this class is just the guess and check method. So we start by 2 sets of parentheses, right? We've got to do that step. If you can't get at least this much, I don't know if I have hope for you. You can do this, though, right? And then our first slot, right? Remember, we want two things that multiply to get the first term. So x times x gives us the x squared term. Now, the second slot, remember, we want two things that multiply to get this. Now, there are several options, right? So for 64, we've got 64 and 1. We've got 32 and times 2. We've got 16 times 4. And we've got 8 times 8. Right? So we've got all those different options. So we guess and we check and we see which one works. And we're gonna jump to the finish line, I think, because you've had some practice with this before. So we're gonna put an 8 and an 8. Now remember, I call this guess and check method the smiley face. We're gonna draw our nose and our mouth. 8 times 1 is 8. 1 times 8 is 8. Can we add or subtract these to get this middle term? 16. 8 plus 8, so positive equals positive 16. Does the sign work at the end? Positive times a positive is a positive. That works. So now you notice this, in this case, our factors are actually the same. So we only actually have one answer to this one, right? Because the factors are the exact same. So we really only have to do this once. So we're going to subtract 8 on both sides. x equals -8. Done. Let's do another one. All right, so this one, we're going to actually kind of do this one twice because there's two ways to do it, and I want you to think about what's going on here and the two different ways to do it. So we're going to start by solving it by factoring, right? And so if we're going to solve it by factoring, if you're wanting to factor a thing, our first goal is to get everything on one side and 0 on the other side, which we don't currently have. So we would subtract 64 on both sides, right? That would cancel. We would have x squared minus 64 equals 0, right? So now we have a difference of two squares. Now, so remember back in your review, go back and look at your review notes, all of those things. If we have a difference of two perfect squares, then we start by two sets of parentheses, square root of the first one, so x and x, square root of the second one, so 8 and 8. And then we do plus and minus. So our answers would be x equals -8 and +8, right? So let's look at this one a different way, right? So let's start again. X squared equals 64. Now, this time, we can notice the fact that we've got x squared already by itself, and we have an opposite operation to squaring something. The opposite of squaring something is square rooting something, or as they say in Europe, they say unsquare, right? So we can square root this, take the square root of both sides, right? Now, here's the trick, and here's what you have to remember, right? Because the square root of 64 is 8. But the thing that you have to remember if you do it this way is if you take the square root, or in fact any even root, 4th root, 6th root, 8th root, etc., right? So if we take the square root of both sides, then your answer is going to be plus or minus. X equals plus or minus 8, right? Which is the same as this. Now, why is that true? I'll remind you really quickly. It's because if we take 8 squared, we get 64. But if we have -8 squared, we also have 64. So both of these answers can go into here, and we'll get the right answer. So let's do one more. We're going to do 2 more total examples, and then we will be through with this one. So let's look at the next one. So we've got another trinomial here. We're going to do our same setup. This time we're going to do 2 sets of parentheses. That's an easy step, equals 0. So 2 things to multiply to get the first term. So x and x. What are our options for 20? We got different options, right? We've got 20 and 1. We've got 10 and 2. We've got 4 and 5. And I think that's it, unless I'm forgetting any. So how are we going to get this to work? Well, let's try 4 and 5 and see what happens. So smiley face. 4 times 1 is 4. 1 times 5 is 5. Can we add or subtract those to get 9? Yes, we can. Positive, positive, positive. Follow our nose, follow our mouth, put a plus. Right? Then we're going to split it into 2. So x plus 4 equals 0, and x plus 5 equals 0. This is algebra 2, isn't it? Right? So x is going to equal -4, because we subtract 4 from both sides, and it's going to equal -5 because we subtract 5 from both sides. Blammo. That was ugly. Blammo. Little better, right? One more, and then we are out of here, right? I'm kind of going quick, by the way, because this is all review. And so we have even more discussion of this. If you need even more than what we're seeing here, this is a bunch of examples. If you need even more examples, you can go back and look at the Unit 0 lessons as well, and you'll have even more examples. This last one is a little bit tricky because this time our A isn't 1, right? So we have different options for that first term. For 6, we have different things. We can do 6 and 1, and we can do 3 and 2, right? For 20, we can do 20 and 1, 10 and 2, 5 and 4, right? So let's do our 2 sets of parentheses. We can do that much. You got this. So what do you want to pick? Let's try 3 and 2. 3x and 2x. And let's try 10 and 2. I don't know, maybe. 10 and 2. Let's do our smiley face. Smiley face in here. 10 times 2 is 20. And then our mouth. 3 times 2 is 6. Can we add or subtract those? Get the middle term, so negative 23. We cannot. Now, here is the important thing. Here is the important thing. Before we change numbers, so let's keep 10 and 2. Change the order as well. Do that first. Okay, so let's change it to 2 and 10 and see if that works. 2 times 2 is 4. 3 times 10 is 30. Can you add or subtract those to get at negative 23? We cannot. So that's still not it. So let's change numbers. Try again. See why we call these guess and check? See why you shouldn't be doing these with pencil on these particular ones? It's just a good idea. Like I said in the review unit, I think this is just like balancing equations in chemistry. It's something that you've just got to try and see what happens. So let's do 5 and 4. 5 and 4. 5 times 2 is 10. 3 times 4 is 12. Doesn't work. So what do we do before changing numbers? We switch the order. So let's do 4 and 5. 4 and 5. 4 times 2 is 8. 3 times 5 is 15. Now we're getting closer. Let's think about that for a second. So 15 plus 8 is 23. And if they're negative and negative, then we get negative 23. Follow our nose and put minus. Follow our mouth and put minus. Do the end signs work? A negative times a negative is a positive. This works. Happy days are here again. We did it. So now we're going to split it into our 2, right? 3x minus 4 equals 0. And 2x minus 5 equals 0. This is algebra 2, isn't it? So we add 4 to both sides. 3x equals 4. And then we add 5 to both sides and get 2x equals 5. And then we divide 3 on both sides and get x equals 4 thirds. Happy. Yay. Divide by 2 and get x equals 5 halves. More happy. That's it. Finished. Done. Hope you enjoyed it. Hope this was helpful to you. Easy peasy. In our next lesson, we're going to be talking about complex numbers, i's and square roots and negative numbers and all kinds of nonsense and fun stuff and funny stuff and who knows what else. If you're one of my students, I'll see you in class. If you're not one of my students, hope this has been helpful to you. We will see you in the next one. Let us know in the comments how else we can help you with math, science, or homeschooling in general. Have a fan-flippin-tastic day. Bye-bye.